You ready? Energy is the ability to do what? Work. Good. What's the minimum amount of work it would take for a 55-kilogram student to climb a 6-meter high flight of stairs? The reason I said minimum, Daniel, is it's possible you could be speeding up or slowing down. There could be a change in kinetic energy. So minimal, I'm assuming they went at a constant speed. Well, then the work would be force times distance. But when you're climbing stairs, when you're lifting, we said the force that you're exerting is always equivalent to gravity. So our shortcut was mgh. So it's going to be 55 times 9.8 times 6. Times 9.8 times 6. You get 3,230. I'll go to 3 sig figs. 3230 joules, 1 mark. That one's kind of an all or nothing. Number 3. What's its total energy? Oh, you know what? Total energy is just going to be the potential energy plus the kinetic energy. It's going to be mgh plus a half mv squared. The total energy is going to be m to g. Excuse me. 9.8. He already has. Thanks. H5. You know what? I can do that in my head because it's really 10 times 9.8. That works out to 98. Plus 0.5 times 2 times 5 squared. The 0.5 and the 2 cancel. I get 5 squared. It's 98 and 25. It's 123. D. Mr. Duick? Yeah, Devin. Why didn't you say 123? You're going to notice on tests, on the multiple choice portions of tests, I often only go to 2 sig figs, and the reason I do that is often when I'm trying to make up wrong answers by guessing what mistakes might occur, if I become more accurate, it becomes painfully obvious that that's a wrong answer. So if I go to 2 sig figs, you still got to know your stuff. It's cheap, but if you're ever wondering why I round off often to 2 sig figs, that's why. Use the following graph of force versus position, force versus distance. Find the total work done in moving an object. Connor, work is what times what? So why can't I just say that the force is 200, don't write this down, and the distance is 5? Why is that wrong? Because it is. Why must that be wrong? What was the condition we attached to the work equation that we kind of take for granted? There was 2. The force and the distance had to be in the same direction. That was 1. What was the other one? This equation only works when we have a blank force. When we have a blank force. Begins the letter C. C-O. C-O-N. Constant force. Do I have a constant force? No, it's increasing. That's why you cannot do that. And I guarantee there is going to be at least one force versus position or force versus distance graph on your test, and I'll tempt you to treat it like a constant force, and every year there's kids that just go, oh, it's 200 times 5. No, not if I give you the graph. We have 3 definitions for work, Bryce. Connor, the first definition, work is what times what? Justin, the third definition was the work energy theorem, change in potential plus change in kinetic. But the second is, it's the area under a force versus distance graph. It's this area here. Mackenzie, I'm going to divide it into, so I can't do that. I'm going to divide it into a triangle and a rectangle. And I'm going to do the rectangle first because it's clearly 2 times 200. It's length times width. It's 400. I'm doing at least 400 joules of work. I crossed out C and I crossed out D because I know the answer is bigger than that because there's still more area. If you haven't reached the point, Daniel, when you're writing a test that has a multiple choice component, if you haven't reached the point that every time you make a discovery, you go and cross out wrong answers, start doing that, Trevor. It's about time you figured out that test writing skill. Most of you are going to post-secondary. Most of you are going to be writing tests in the future in post-secondary. I've just changed this from 1 out of 5 to 1 out of 3, I've increased my odds even if I have no idea what to do next. Oh, I do know what to do next. I'm going to find the triangle area. A triangle is base times height divided by 2. I can do that in my head, because what's 200 divided by 2? 100 times 3, 300. This is 300 plus 400. The answer is B, yes? No calculator necessary, because... Number 5. Suppose this represents the work done. Find the speed of the mass. There's a good chance, as a written question, I might combine 4 and 5, but not walk you through the steps. I might just say, Pierce, how fast are we going? And you would have to realize, oh, there is an equation that has how fast, a half mv change in potential plus change in kinetic, and work, the work energy theorem. Oh, and the graph tells me the work. In this case, I'm going to say work equals change in potential plus change in kinetic. I have to assume that. On a test, I would tell you over level ground. The work was 700. What's change in anything, Connor B? What's my initial kinetic energy? It says the mass is initially... So what's my initial kinetic energy? So it's a half mv final squared minus a half mv 0 squared, or v initial squared, but I'm not going to bother writing that because initial is 0. So it's going to be that. How will I get the v by itself? Times by 2, divide by m, square root. Yes? So 700 times by 2, divide by 4, square root 18.7. Okay. Yes? Number 6. Number 6. Pierce, what's number 6 asking me to find? Power. So my first thought, I have 2 equations for power. My first thought is work over time. I'll write that down, but I would normally just think it. And then I would go say, well, did they tell me a time? Pierce, did they give me a time in this question? What? Oh, they were sneaky. They wrote it out in English, so time is going to be 60 seconds. I'll try this approach first. If they had not given me a time, I might also try the fact that it's force times constant speed. Maybe they gave me a speed, or maybe I can figure out a speed. Here they gave me a time, so you said it's going to be 60. What's the work when you're lifting an object? How do we calculate that? MGH. So it's going to be over 60. What's the mass? Well, it's 20 people and 60 kilograms each on average. G is 9.8. The height is 5. Believe it or not, Taylor, that 60 and that 60 end up canceling, and I get 100 times 9.8. I can do that in my head. The answer is 980. I don't see 980. Oh, for Pete's sakes. To 2 sig figs, it's 1,000. Well, to 1 sig fig, it's 1,000. Okay. Oh, and power is measured in watt? Watts. Power, scalar or vector? Yeah. What's everything in this unit been pretty much? Yeah, scalar. Which is why you've noticed nowhere near as much trig, right? How much work is required to stop a car? How much what? Work. Connor, work is what times what? I don't see a distance in this question. Work is also the area underneath the force versus distance graph. I don't see a graph. Justin, what's our third definition of work? I'm going to assume we're on level ground. On a test, I would say we're on level ground. What's my final potential energy, kinetic energy? Because it says stop. So I'm going to get this. Work is going to be 0 minus a half mv squared. I am going to get a negative answer. I glanced at my answers, Mackenzie. I noticed they're all positive. I didn't freak out. This negative is not a directional negative. This negative is just saying you have to lose that much energy. So if they didn't put the negative in their final answer, I think they're assuming that I'll clue in it's an energy loss. And the word loss is the English version of a negative, so I don't need to put it in front of the number. Is that okay? So it's going to be 0.5, 1,200. Why is that wrong? Oh, I got to divide by 3.6. And I'm lazy enough, I'm going to do that all in my calculator. Half m, and then in brackets, 10 divided by 3.6 squared. And I get B. Yes? Next page. So far, since they're multiple choice, they've been all or nothing. Tarzan. He starts out 2.5 meters above the ground. He swings. He ends up 2.4 meters above the ground, which means he's lost some energy. Where'd that energy go? I guess air resistance as he's bumping into air molecules, friction in the rope will lump that all, Emily, into friction. So A asks, how much work has been done by friction? What was another synonym for work done by friction? Began with the letter H. Okay, so I'm going to... is there a change in height? Yeah. Is there a change in speed? Yeah. Is there a yucky curvy path? Yeah. I know it says how much work, but it's saying how much work is done by friction, which is heat. This is a job for conservation of energy. G. So I'm going to go like this. Are any of these 0? I think we're going to assume Tarzan starts at rest, and when he gets to the other end of the swing, he ends up at rest. Okay? How would I get the heat by itself? How would I get the heat by itself? Okay. I wouldn't do it that way, because I'm clever. Here's what I noticed when I was doing this question. One of the beautiful... By the way, absolutely, if you minus the MGH and go to town, you'll get the same answer as the method I'm about to show you. Devin, one of the beautiful things about work and energy, it's a scalar, which also means I can put 0 height wherever the heck I want. I decided to make the height of 0 right there. So I decided to say that's 0, and my initial height is 0.1. It's going to work out the same, Em. It will. And I thought it was kind of clever, because then that gives me this. The heat is going to be M G times 0.1. And then I said, you know what? 9.8 times 0.1, this is roughly 10 times 0.1, this is almost 1, this is almost 75 times 1, it's a little less than 75 times 1. Which answer is a little less than 75 times 1? The answer is A, is it not, if you do it the long way? And you don't have to do it the way that I just did, but I'm letting you know, sometimes you can be clever and save yourself, no pun intended, some work. Yes, Daniel, pun absolutely intended. Yes, true enough. Okay, it is if you go MGH final or initial minus MGH final, you get the same thing, yeah. And here, because of heat, mass doesn't cancel. If there were no friction, what would Tarzan's speed v be at the bottom of the swing? There's a change in height. There's a change in speed. There's a yucky curvy path. They're asking for a speed. KE initial plus PE initial equals KE final plus PE final. I think my final potential energy is at the bottom 0. My initial kinetic is 0. Devin, you going to make it? You sure now? I get that. In this case, the M also cancels. You don't have to, but it does. How would I get the V by itself? V final is going to be 2 times G times H initial square rooted. Can I do that in my head? What was H initial? Well, let's write out the numbers first of all. 2 times 9.8 times 2.5. 2 times 2... Oh yeah, I can do this in my head. 2 times 2.5 is 5. Everyone knows that 5 times 9.8 is 49. Square root of 49 is 7 even, yeah? No? Yes? Yeah. You good? Next page over. If I haven't said so already, I'm going to tell you, there's going to be a roller coaster on your test. All right. It looks like initial is right here, and for part A, final is right there. I jotted that down just to give me a frame of reference. It wants the speed. There's definitely a change in height. There's definitely a change in speed. There's definitely a yucky, curvy path. This is not work. This is a job for conservation of energy. So it's going to be kinetic initial plus potential. Initial equals kinetic. Final plus potential. Final. And the only thing that canceled here was that bad boy. A half mv initial squared plus mg h initial equals a half mv final squared. Connor, have you been on a never mind. Have you been on a roller coaster before? You have? When you went on the roller coaster, did you have to step on a scale? No, they didn't have to spread out the heavy people and the light people. Why not? Yeah. Now, what if we included friction? We would have heat there, and it's true. So in our magic physics world, masses cancel. In the real world, what you would do is you would minimize heat by minimizing friction, by using lots of axle grease, basically. And so you can make it negligible. That's why an empty car and the full car can make it through the cycle without suddenly stopping partway up a hill and sliding back down and just ending up at the bottom there. I'm also going to go times by 2, times by 2, times by 2. You don't have to. You can make all those 1/2s 0.5s. You'll get the same answer, Alec, but I like to try an elegant solution if I can. And also, I notice I foolishly forgot a squared there. Don't do that. You're going to get VI squared plus 2GHI equals VF squared. How to get rid of a squared? Square root. You're going to get VF equals the square root of 4. Was it 4 squared was VI and 18? Plus 2 times 9.8 times 18. 4 squared plus 2 times plus 2, Mr. Duick, plus 2 times 9.8 times 18. Square root of that. You get, is it 19.2?
Yeah.
How fast is that? Times by 3.6. 70 kilometers per hour. Fast-ish, but not. This is not a world-class roller coaster, but this is not a kiddie ride either. 19.2 meters per second. How fast is it traveling at the top of the second hill? This one is a bit trickier. Now, final is right there. The reason it's trickier, Emily, stuff's not going to cancel as easy. In fact, I don't think anything cancels. Okay. It's still a change in height. It's still a change in speed. It's still a yucky, curvy path. I'm going to get a half mv initial squared plus mg h initial equals a half mv final squared plus mg h final. I mean, the m's cancel still. And I'd still go times by 2, times by 2, times by 2, times by 2. I'd still multiply everything by 2. And that's going to give me vi squared plus 2ghi equals vf squared plus 2ghf. I'm going to minus that to there. I didn't leave much room to write here. I'll get vf squared equals vi squared plus 2ghi minus 2ghf. How to get rid of a squared? Square root. If you plug in the numbers, was vi 4? I think. Oh, you know what? If I'm really, really clever on my calculator, if I just backspace a few. There. 4 squared plus 2 times 9.8 times h initial. Yeah, that was a little saving. Minus 2 times 9.8 times... What was the height of the final hill? 10? 106. That seems high. That never happens. By the way, I've lost track of how many times on this test, on the very last question, on the very last line, kids forget the squared or the square root because they're so psyched. They've done all the typing, they finished the test, and they let their guard down. Don't be that. You get 13.1? 4 out of 4 if you got that. Otherwise, I would probably go 1 mark. 1 mark. I would give you 1 mark if I saw that. 1 mark for the answer. On the previous line, I would probably go 1 mark. 1 mark. 1 mark for the answer. But if you got it right, 3 out of 3. Can you give yourself a lovely score out of a 16, please?